Alright, let us talk about symmetric encryption. Although I have told you about symmetric encryption in one of the previous lectures, but it was just an overview. So what is symmetric encryption? Well, from this name symmetric encryption uses the same key to encrypt and decrypt the message. So the key which you use to basically generate the plain text, to generate the ciphertext from plain text, the same key you use to generate the plain text from ciphertext. So first, you generate ciphertext from plain text, and while decrypting, you generate the plain text from ciphertext. So basically, symmetric encryption uses a mathematical algorithm. As I said, cryptography is all about mathematics. It's all about prime numbers, modular arithmetic, then pseudo-random numbers. It's all about mathematics. So it uses a mathematical algorithm to encrypt and then decrypt the data using a single key. So what you have to remember when you are asked about symmetric encryption is you have to remember single key. It's a two-way algorithm because first you encrypt and then you decrypt. So first you encrypt, then you decrypt. That is why it's known as a two-way algorithm. It is also referred to as private key encryption or secure key encryption. Now, why it is referred to as private key encryption? The simple answer here is you have only one key, right? You have only one key here, and that key is supposed to be kept private. As I said, if you're communicating with a person, that person should also have the same key, because if you're going to unlock a message or unlock a box with one key, and if you are using symmetric encryption, then that person should also have a copy of the same key, exact same key. So in that case, if when you are traveling, as I gave the example of a house and your wife, so those I gave the example in the context of asymmetric encryption because I just wanted you to tell you that if you're unlocking with one key and then you can lock with another key. But actually that example was of symmetric encryption. Only the context was different. Because why it is a symmetric encryption? If you're locking your house with one key, then your wife should also, or your husband should also have the same copy to unlock the lock, right? So the context, though the context was asymmetric encryption, now I'm using the same example for symmetric encryption. So why it is called private key? Because we have seen asymmetric encryption has two types of keys, public key and private key. Private key is the key which you keep to yourself and which you use to encrypt or decrypt the messages. And public key can be of public knowledge. Anyone can know it. So do you want the key of your house with everyone? Do you want everyone to have access to your house? Well, no. That is why this key is supposed to be kept private between the communicating parties, and hence it is known as a private key encryption. Well, again, private and secure are synonyms, so it's also known as a secure key encryption. So if anyone asks you, hey, please explain me about secure key encryption, you shouldn't confuse. Well, secure key, secure key, secure key. Right. Symmetric encryption. So now let us have a look at the examples of symmetric key encryption: blowfish algorithm, two-fish algorithm, advanced encryption standard, data encryption standard, reversed cipher 4, 5, and 6 versions are a few examples of symmetric key encryption. Well, one of the drawbacks of symmetric encryption is the secure sharing of keys. How are you going to exactly share those keys? Because even you have to share a key over email, you have to keep that key confidential. So again, you have to encrypt that key. But if you're using symmetric encryption again and again and again, the keys need to be shared. So secure sharing of keys is a tough problem, but Nothing is tough for people who are curious. So there were two people, Diffie and Hellman, together. They solved this problem and they proposed a new solution to this, which was Diffie-Hellman key exchange algorithm, in which this key is shared securely without using some other factors. Well, what is the advantage of symmetric encryption? You must ask, if there are two keys and if that is more secure, why have symmetric encryption in place? Well, the most fundamental advantage of symmetric key encryption is speed. Symmetric key encryption is much faster than asymmetric encryption. It's much faster. Although you think that asymmetric key is much secure, it's not used that much because of its extreme consumption of power. Symmetric encryption, since it uses same key, it has a predefined process to do. That is why the task of encryption and decryption requires, it's a speedy task. Less time is required in order to carry out the entire process. So drawback is secure sharing of keys, but again, there were two brilliant people out there, Diffie and Hellman, who proposed the Diffie-Hellman algorithm. So to sum up, what you have to remember when it comes to symmetric key encryption is same key is used. Okay, I'll just mark it again. So same key is used, mathematical algorithm, single key, two-way, private key encryption, and these are a few examples. And again, you have to remember S for speed, S for symmetric encryption. The only drawback is again S, that is secure sharing of keys. In the next lecture, we'll talk about a few examples of symmetric encryption. We'll see different algorithms, the key size, what is the key size for those algorithms, what is the input, and what is the exact output. Okay, I have got this question a couple of times. What is the input? Well, you cannot give a Word document at a random, right? There is fixed input size for each of different algorithms. And only in that algorithms, the data is encrypted. You cannot give 2000 characters to encrypt as a single block. So there are different various block sizes in case of symmetric encryption, which we will be seeing in the next lecture. All right, keep the momentum going. You're doing a great job. If you have any questions, do let us know and I'll be happy to solve them for you.